Tilt and barrel rotation are how we describe the orientation of a pen relative to the drawing tablet. Many people have an intuitive sense of what tilt means, but at the same time, I often see that they misunderstand it. Support for tilt detection is very common in drawing tablets, but barrel rotation support is very rare. And so I often see people asking exactly what barrel rotation means. And sometimes people get these two concepts confused with each other. In this video, I'm going to make these concepts clear. And once we are done, you'll know exactly what tilt and barrel rotation are and how they're different. And then in separate videos, I'll get to the details of both tilt and barrel rotation. I'll show you how they work, I'll explore some of their limitations, and I'll show you how to apply them to your brush strokes. As I said at the beginning, tilt and barrel rotation are ways we describe the orientation of the pen relative to the drawing tablet. This orientation is composed of three separate angles. In other words, we are describing three separate rotations of the pen. There are two angles for tilt. These are the tilt altitude and tilt azimuth, and the third angle is barrel rotation. I'm sure some of you have probably never heard of some of these terms, especially azimuth, but don't worry. In this video, it will become extremely obvious what each one of these three angles means. What you see here is a 3D simulation of a drawing tablet and a pen. This tool makes it really easy to visualize the three angles, which is not possible when we're using a normal camera. To start with, the pen is oriented perpendicular to the tablet. There's a dark region directly below the pen. That's the shadow of the pen. This shadow will be a useful guide to what's actually happening as we orient the pen. You see some dotted circles in this simulation. These dotted circles will help us visualize and understand how these three angles rotate the pen. Let's start with tilt altitude. The pen starts perpendicular, but as we change the tilt altitude, the pen leans over. The tip of the pen stays in the exact same place on the tablet, but it's the top of the pen that falls down towards the tablet. The purple dotted circle shows you the tilt altitude angle as a pie slice. It should be clear now why the word altitude is used, because it relates to how high the top of the pen reaches. Notice the shadow. As we tilt the pen more, the length of the shadow increases. Now let's take a look at tilt azimuth. The practical explanation of azimuth is that it's like the compass direction on a map. Effectively, it's an angle that describes whether you're going north, south, east, or west, etc. Or you could think about it as a clock. You know, some people use clock hands to tell the direction of something. So they might say that there's somebody standing at 3 o'clock. These explanations might seem a bit abstract, but as we change the tilt azimuth, the effect is very obvious. The green dotted circle has a pie slice that shows you the tilt azimuth angle. The pen shadow also adds a very clear visual clue, because the shadow in this simulation always matches the azimuth angle. The more mathematical way of describing barrel rotation is that the pen is rotating around its long axis. And this is another case where it's easier to just see the barrel rotation rather than trying to understand this definition. And one more thing, I think barrel rotation is the right term for this. You may have seen that Apple, with its Apple Pencil Pro, calls this barrel roll, which I don't think is the right term for this. As the barrel rotation angle changes, the pen just spins in place. The orange dotted circle has a pie slice that indicates the barrel rotation angle. Notice that the change in barrel rotation has no effect on tilt altitude or tilt azimuth. And because it doesn't affect those angles, the shadow of the pen doesn't change at all, no matter how I change the barrel rotation. These three angles are completely independent, so they can all apply at the same time. And just to have a bit of fun, Let's take a look at what happens in the simulation when all three of them change simultaneously. Of course, seeing this animation now may not clarify the concepts any better, but at least it does look really cool. And now you understand the fundamental concepts of tilt and barrel rotation. In future videos, I'll explain more about both of these concepts. For example, I'll talk about the technology used to detect tilt and barrel rotation, why barrel rotation is such a rare feature in drawing tablets, and how you can configure your brushes in apps like Clip Studio Paint and Krita to use tilt and barrel rotation. If there are certain topics about tilt and barrel rotation you'd like to see me explore, just leave a comment. Thanks for your time, and I hope you enjoyed this video.